morning students. Today we are going to see the power plant in engineering class number 3. First class we discussed about different energy scenario in India, and the second class we discussed different vapor power cycles. We discussed about Rankine cycle, Rankine reheat cycle, Rankine regenerative cycle, and Rankine regenerative and reheat cycle. Then we are discussed about binary vapor cycle, then toppling cycle and bottoming cycles. Those things we discussed in the previous class. Today we are going to see what do you mean by a boiler. So the boiler is a device which converts the water into a steam. The boiler is actually a heat exchanger. The boiler takes the heat from the flue gas. The flue gas is coming from the combustion of the fuels. The chemical energy in the fuels is converted into heat energy by the combustion process. So the boiler is a device which converts the water into a steam. Let us see what is a clear idea about the boilers. A steam boiler is simply a boiler, basically a closed vessel. The boiler is a closed vessel into which the water is heated until the water is converted into a required steam. The steam not only getting the heater convert from liquid form to vapor form, it is also pressure is increased. The pressure get increased, but as it was a closed vessel. As it is a closed vessel, what will happen? The volume goes on increasing when you are doing the heating process. So because of that, the pressure is increased. Right? The most basic definition of the boiler, right? The boiler is a device which converts the water into a steam to the required temperature and to the required pressure. If you are going for the boiler, there are two types of boilers are there. A major classification. One is going to be a fire tube boiler, another is water tube boiler. In case of fire tube boiler, the flue gas passes through the tubes. The water is around the circumference. In case of water tube boiler, the water is going through the tubes. The flue gas surrounds that particular tube. Right? So in the fire tube boiler, there are number of tubes through which the hot water passes, and the water around the tubes. In water tube boiler, it is a reverse. The fire, right? In the water tube boiler, the water is going through the tubes and flue gases surround it. So the heat transfer is taken place. So that is the difference between two types of boiler, fire tube boiler and water tube. Fire tube boiler, the flue gas passes through the tubes. In water tube boiler, water is passes through the tubes. But both are heat exchangers only. So after that, seeing the definition of the boiler, we will see the different types of boilers are available, which are used for high pressures, and high quantity, the volume, high quantity as well as high pressure. Those boilers is what we call as high pressure boiler. In the high pressure boiler, in most of the power plants, medium sized power plants, they are using the lemon boiler. The lemon boiler is one of the oldest boiler which is used for from the long period of time. The lemon, right? If you are going for any boilers, these boilers are having a minimum required devices. It will have the economizer, it have the superheater, it have the combustion chamber, air preheater, blowers, right? So all these things, these are all common for all the boilers. All the boilers now we are going to see is only the water tube boilers. We are not going to see the fire tube boilers in depth. Just we will see what is meant by fire tube boiler. Most of the thermal power stations are using water tube boilers only because they can go for a higher capacity as well as a high pressure also. The water tube boiler is having high capacity. High capacity means it is tons of steams we can generate per hour, and also high pressures, 170 bars, 150 bars, more than that is 150 times of atmosphere they can produce. So if we are going for this, a lemon boiler, the lemon boiler is the simplest boiler. So most of the industries, the medium scale industries, power plants are using these lemon boilers. Processing industries are mostly using only the fire tube boilers. If you are going for large scale production only, they will go for water tube boilers. Right? So if you are going for this lemon boiler, the lemon boiler, first we will start with the what we call as a feed pump. From the feed pump, I will just explain this diagram. See this one, the water is coming from this feed pump. It is coming to the economizer. Right? Then from the economizer, the water is pumping, right? The water is going to this particular superheaters. Going to the particular superheater. From where you can see the water is coming from the feed pump. It is coming to the steam drum. From this steam drum, the water is coming to the circulating pump. From the circulating pump, the water is forced to the boiler. That means to the combustion chamber. It is coming to the combustion chamber. The water is converted into steam. But if you are converting this into steam, the water is not fully converted into vapor. Not complete vapor is forming. Some water particles are present. That wet steam. In this chamber, what is actually happening is the water is converted into a steam, but still there may be some water droplets are presented. That is wet condition. The X is less than 1. X is equal to 1 means dryness fraction. Dryness fraction is less than 1. Then the same steam is coming to the boiler drum. Back again. In the boiler drum, what will happen? The steam separation is taken place. Right? The water is droplets are deposited again back, and only the steam. Right? This is going to the superheater. That is going to the superheater. There it was superheated and sent back to the superheated and go to the turbine. And again, if you want to increase efficiency, what they are doing, from the feed pump, that water is coming to the economizer, where that water was preheated. That water is also coming to the boiler drum. From the feed pump coming to the drum through the economizer. The economizer is a device which converts not fully convert, which will heat the inlet water. Taking the heat from the flue gas. Right? Air preheaters also there, which preheats the air before it was entering to the combustion chamber. Right? So this is a simple construction. Then we will see one by one what are the different components and what are its functions. The first and foremost function is that lemon boiler. This actually, as we have discussed, we are having the circulating pump. So this boiler is going to be in centrifugal type. Forced circulation. Centrifugal pumps are used to increase the pressure. So because of that, the water is going at the high pressure. So it is forced circulation boiler. Right? The water is circulated, and then we will see the different components. What are all the components are there? The first, the steam separated drum. It is not kept inside the combustion chamber or inside the boiler, what we call it as. It will kept outside, at the side. The drum receives a mixture of steam and water. That's what I said previously. It having wet steam. Dryness fraction not equal to 1. Dryness fraction is less than 1. Right? So from the water, then see the drum receives a mixture of steam and water from the evaporated tubes. And feed into the water to the economizer. The water particles or steams are separated. The water particle, the steam drum, it is a separator. Steam drum separator means it separates the water as well as the vapor. Both will be separated. Then the water circulating pump. The water circulating pump is a device which circulates the water at high pressure. That may be more than 80 to 70 atmospheric bars. Right? The pump plate circulates the forced circulation equal to 8 to 10 times of weight of the steam evaporated. 10 times capacity. That prevents that tube. The water tubes, if the water is flow through the tube, the salt sedimentation is there. The formation of sedimentation will be removed, right? Avoided by using the forced circulation. So the first one is going to be steam separator. Next is water circulating pump. Next one is going to be distributor head. Distributor head means through which the water is passed through the different evaporated tubes. 3 or 4 lines are there. It is distributing. Evaporator evaporates the water into steam. Evaporator is going to be evaporates. That is in water conversion. Phase change is taken place in the evaporator. It is used to evaporate the water into steam. Convection superheater. There are 3 types of heat transfers are there: conduction, convection, radiation. These superheaters are going to be in convection. Convection means it is momentum of molecules. Will be there, right? So this type of superheater is avoid the corrosion. It increases the temperature more efficiently compared to the conduction superheater. Convection is better because direct contact with the things. So because the molecule movements will be there, so it is easily converted into wet steam to superheated steam in the convection superheater. The next one is going to be an economizer. The economizer is one of the device which increases the boiler efficiency. Boiler efficiency, it takes the heat from the exhaust gases which is going out as a waste. The main purpose of the economizer is to preheat the feed water using the exhaust gas flowing out from the boiler to the atmosphere, which is after superheated it is going to atmospheric gas and waste. The flue gas, some heat is there, that heat will be recovered. Right? The preheat water recovered only a small amount of heat supplied into the boiler. This will increase efficiency of the boiler. Right? In this, the feed pump is pumping the water to the economizer, to the header to the economizer, on the way it's to the separator. Before going to the steam separator, it was preheated. Then air preheater. Right? If you are going for the air preheater, this air preheater is preheats the air, supply the preheats the air. So if once the air is going with the preheated condition, the combustion is easy. Combustion is easy. So for that purpose, we will have the air preheating. Air preheaters are used. So next is we are going to see the lemon boiler, how it was working. How it was working. The feed water passes through the economizer to the drum. The same thing we again explain, from which it is brought to the circulating pump. The pump delivers the water to the product circulating through the higher value, high quantity, 8 to 10 times of the boiler's capacity. Alright, the steam drum is mixture of steam water. The steam is drawn through the convection superheater. The convection superheater. The superheated steam is supplied to the prime mover through the steam outlet. Prime mover means it is going to be a turbine. Right, the main important, see the working pressure and the capacity. The working pressure of the lemon boiler. Working pressure of the lemon boiler is very important. High pressure. That is why we discuss it is high pressure, high capacity. See, 50 tons, 50,000 kgs. 1000 kg is going to be 1 ton. 50 tons per hour. Imagine how much pressure and how much quantity it is going out with a temperature of 500 degrees centigrade. 500 degree centigrade. The working, already we have seen the critical temperature is between 350 to 400. So this boiler is producing the steam at the temperature of 500 degrees centigrade. 50 tons capacity per hour at the pressure of 170 bar. 170 bar. So that is the beauty of the lemon boiler. So what are the advantages? This boiler is a forced circulation. As we discussed forced circulation, there is no formation of sedimentation on high working pressure. High working pressure. The same comes as a disadvantage. If the salts or sedimentation is deposited on the way, it leads to bursting of boilers. Bursting of boilers. This is what we say is the danger of overheating of boilers. Any blockage which leads to an overheating of boiler tube. That is the disadvantage of lemon boiler. These difficulty may be overcome by another boilers. So that boiler is Bunsen boiler. Bunsen boiler. The Bunsen boiler and lemon boiler difference is the Bunsen boiler is not having separate boiler drum. The lemon boilers have the separate drum. From drum they are separating. But instead of drum, what they are doing here is they are doing two types of superheaters. Right? Two types of heaters. One is going to be convection heater and another one is going to be superheater. Convection heater as well as radiation heater. Both the things they will be used. They are using two. They are using two. See the combustion chamber, near to the combustion chamber, the normal tubes will be there. So there steam is converted, water is converted into a wet steam. Not complete superheated steam. Some temperature will be raised, still there may be some dryness fraction. That steam is going back, right, to the superheater. To the superheater. Then from the superheater is going to the prime mover. Right? So in the lemon boiler we are having two pumps. One is feed pump, another is circulating pump. But in the case of Bunsen boiler we have only the feed water pump. The feed water, the water is pumping from the pumping station to the economizer. From the economizer it is coming to the convectional superheater. Convectional evaporator or convection superheater. Convection heater. From the convection heater it is coming to the superheater. Coming to the superheater, it is going to the turbine. It is going to the turbine where the mechanical energy is converted into electrical energy. Here the steam will have the kinetic energy. That kinetic energy into mechanical, mechanical to the electrical. Then it is also having the air preheater. We will see what is the construction and what is the working principle of Bunsen boiler. So the Bunsen boiler, right? So only the difference, see here. In lemon boiler, the main difficulty experienced is the formation of attachment of bubbles in inner surface of heating tubes. Because the water vapor which is separated out, when you are going inside, because of the convection process, overheating process, the formation of bubbles as a direct contact. in the boiler tubes, the lemon boiler. That difficulty is maybe overcome in this Bunsen boiler. The attached bubbles on the tube surface are reduced the heat flow, and steam generation offers high thermal resistance than the water flame because of high thermal resistance of the water flames. This difficulty over by the Bunsen boiler. So we can see the heat flow on the steam generation as it offers a high thermal resistance than the water flame. That is a difficulty in the lemon boiler that can be avoided in the Bunsen boiler. They are going for Bunsen. This is the first drumless boiler. All the boilers almost having the boiler drum. The beauty of Bunsen boiler is not having the boiler drum. Then we will see what are the different components are in the Bunsen boiler. All the boilers will be the same components. Economizer, all these things. We will see even one by one. So if you are going for Bunsen boiler, first and foremost is economizer. Economizer device, we all knows the economizer is device which preheats the inlet water before supplying to the boiler. Preheats the water before supplying to the boiler to get easy evaporation. Right? Radiant evaporator. The feed water from the economizer flows to the radiant evaporator, in which water gets evaporated and partially converted into steam. Not fully. Radiant evaporator, not fully, with at most the dryness fraction is 0.7. 0.7. Right? 0.7. But the working steam at least should have X value, the dryness fraction of 0.85 minimum requirement. There may be little permitted, but most of the boiler they are using superheated steam only. During expansion, it may be going for little wet. The how much is permissible is 0.85. 0.85. So the radiant evaporator receives the heat from the burning of fuel through the radiation process. That is why we call it as radiant evaporator. That heat transfer is taken place by the radiation, not with the direct contact. The next is going to be a conventional evaporator. Conventional evaporator. The remaining water which is coming from the radiant. So if you are going for the radiant superheater, right? Radiant superheater is there. The radiant superheater is there. So from the radiant superheater, it is coming to the convection superheater. The bottom is going to be a radiation superheater. Radiation superheater. By direct contact with it is going to be because of near to it. It's next to the combustion chamber. So the heat is absorbed through the radiation process. Next it is going to the convection evaporator. Convection evaporator. Right? So the convection evaporator, the water is evaporated still from 0.7 to 0.8. 0.8 the supersaturated steam at the pressure of 210 kg force per centimeter squared. 210 kg force per centimeter squared. That much pressure it can produce. Lemon boiler previously we have seen 170 bar. This one is going to be in 210 kg force per centimeter squared. Right? Then it is going for the convection superheater. The superheated steam is available in the convection evaporator. Convection evaporator. The superheated in convection superheater and superheated steam is supplied to the turbines. Steam turbine. That means increased kinetic energy. That means how it is there? Because of high temperature and high pressures. So that the steam is going to the turbine, which converts the kinetic energy into a mechanical energy. What is the working principle? How it was working? The Bunsen is all heating. Steam generator, superheater is done in the single continuous tube. Same tube. In the lemon boiler, there are 3 tubes. One is coming to the economizer, right? Another is coming to the forced circulation pump. Another from the air preheater, it is going heating through the convection. It is going there back to the boiler drum. There, the water molecules are separated. There are 3 tubes are going in and out. But in case of Bunsen, it starts from the feeding, then it is coming out at the steam at the one end. That only one pipe is going here and there, right? Everywhere. It is coming one point and going with the another point. The same pipe is going, continuous tubes. The feed water after circulating the economizer tube flows through the radiant parallel tube section and evaporate partially at the down. The remaining water radiant is evaporated into a convection evaporator of the hot gases. The saturated steam available. Saturated steam means it is having some amount of water, right? Available evaporated passes through the convection heater, right? Where it is superheated. Finally, the superheater supplied to the steam turbine outlet. The Bunsen boiler, see, as we discussed earlier, the lemon boiler is generally used for the medium stage power plants, but that is capacity of 50 tons. But the Bunsen boiler is 750 tons per hour. Imagine how much amount of water it takes and how much amount of fuel it may burn to get into a steam, right? That is a Bunsen boiler. So what are the advantage of the Bunsen boiler compared to the other boilers? So if you are going for this Bunsen boiler, it is, as we are not having the boiler drum, it requires only the small area. So as there is no separate standing, the weight is also less compared to other boiler. It can start very quickly. Circulating pump and down comers are dispensed. It's removed. Circulating pump is not at all there. Only feed pump is there. The furnace of the boiler more efficiently protected with smaller diameter. Because of smaller size, we can easily protect. Easy for transportation. They can easily transport it. It can be operated economically, varying the temperature or partial loads. Whatever may be the requirement, according to that we can feed the water. According to that we can combustion the fuels. Right? So whenever it wants overload also, we can pump more amount of water and combustion of more fuel flue gases. So the quantity requirement may be increased. Right? Blow down losses. If you want to switch on and switch on, it takes more time. The losses will be less compared to the lemon boiler. No special starting arrangement. Superheater is required. Directly this one pipe is passing. So the same water is circulated in and around. So separate superheater is not required. Other boiler, first we have to initially start with the some superheated steam initial stage. Then we have to circulate the steam again. Right? But Bunsen boiler, same water is going, no need of separate heater and other things. So we have seen the lemon. So disadvantage of lemon is overcome by the Bunsen boiler. Bunsen boilers are high capacity boilers, high pressure boilers. So capacity is around 170 tons per hour. Right? More than that. In lemon boiler you can see that one, that is for 50 tons per hour. But here you can see 750 tons per hour. Capacity will be more, higher capacities. So thermal power stations are using this. High Neyveli and Ennur, these power plants are using this type of Bunsen boilers. So next boiler we will see Lefler boiler. What is the difference between Lefler boilers and other types of boilers? So it will take the advantages of both Bunsen boiler and lemon boiler. Bunsen boiler and lemon boiler. This Lefler boiler. So if going for Lefler boiler, so all the other components will be the same. All things will be same. But what they are doing in this particular boiler is they are doing combustion. Right? They are doing the combustion as usual with the others. This is one type of fluidized bed boiler. Instead of burning at the bottom completely by the coal and other thing creates, the pulverized coal was sprayed. So that is coming as like a fluid property. So we have the fluidized bed. What is fluidized bed? That combustion chamber having the similar property of the fluid. Similar properties of fluid. So that is why we call it as combustion chamber. Now apart from that, we have seen previously that when going for the Rankine regenerative cycle, this Lefler boiler is using the regeneration principle. Right? In lemon boiler also using in the boiler drum we are separating the steam water droplets only. There we are not doing the preheating of the steam or anything there. But here what they are doing is we take the part of the steam from the boiler to heat the feed water. So regeneration is utilized here in this boiler. That was the beauty of this Lefler boiler. You can see here there may be a feed pump. From the feed pump coming to the economizer where the water is preheated, it is going to the bottom drain where we are having the water coming from the economizer, and then some part of the steam is taken from the superheater. It is coming and mixing with this water. There what will happen, the water is converted into vapor here itself. Right? Because of the superheated steam, the water is getting converted into a wet steam. Then through the steam circulation pump, it is going to the radiant surface radiant heater. Then it is going to be a convection superheater. Then it is going to the steam out. And the way part of the steam is bleed out for converting the water into steam before going to the combustion chamber. So the efficiency will be more. In case of Lefler boiler. And also quantity production also will be high, faster rate compared to the lemon and Bunsen boiler. right? So lemon boiler, the major problem experienced in the lemon boiler, what we have seen in the first boiler, is the deposition of salt. Deposition of that is already we discussed in the Bunsen boiler. Right, rectify the problem, forced circulation is used. The boiler can carry the salt concentration than any other type. It cannot worry about in this type of boiler because two pumps are there. The forced circulation is there as well as feed pumps. Because of the forced circulations, these boilers will not be affected. The water will not deposit. Water sediments will not deposit on the lines. Forced circulation. The same thing will be there in the lemon boiler, but the problem there is even small stuck it will burst. But here we are using two pumps, right? The principle of operation evaporating feed water by means of superheated steam from the superheater. The hot gases furnace primarily used for superheating purposes, right? The steam is used as heat absorbing medium. The other parts, if we see the other parts, same starts with the economizer. The feed water from the feed tank is supplied to the economizer pump. Economizer by the feed pump. The economizer used to preheat the water. Air preheater, water preheater. Economizer is the water preheater. It is a heat exchanger. It is also a type of heat exchanger which takes the heat from the flue gas, exhaust flue gases. Right. The next one is going to mean evaporator drum. Like a lemon boiler, Leffler boiler is also having the evaporator drum. Right, see the feed water from the economizer tubes enters the evaporator drum, which is passed 2/3 of the superheated steam used for heat the water. 2/3 of the steam is taken back after the superheating. 1/3 will be going to the turbine. 2/3 is taken for the conversion of the feed water. Conversion of the feed water into a wet steam. Right, mixing nozzle. Mixing nozzle is mixing of water with the steam. Thorough mixing in the evaporator drum. Right, next one is going to be an steam circulation pump which sucks the steam, wet steam from the drum. It forces steam from the evaporator drum to the radiant superheater. Right, radiant superheater is the heat is transferred to the medium of radiation. No medium is required. This placed in the furnace itself near the combustion chamber. The hot gases in the furnace used to superheated the saturated steam of the drum. Saturated steam which is coming from the steam drum through the steam pump, right? Steam pumping, circulating pump, right? It is converted into superheater. Convection superheater. Radiant superheater enters the convection superheater. Finally heated at desired temperature of 500 degrees centigrade. Most of the boilers heating into 500 degrees centigrade. Even the boiler operating temperature is 350 to 400 degree centigrade, right? The convection superheaters are arranged in series path of flue gases in the series way, right? Series way means it will be like this. Conventional radiation, right? Serial connections will be there. So that is what we call it as a Leffler boiler. So what is the advantage of Leffler boiler? The steam outlet is the 1/3 of superheater, and because 2/3 is taken back, we are getting back for preheating the water. We are converting there itself, because before going to the furnace itself, it will be converted into steam. For that purpose, we are using 2/3. So 1/3 is only going for the turbines. 1/3 is going for the turbines. How it was working? High pressure feed pump draws the water through the economizer and is delivered to the evaporating drum. The steam circulating draws the saturated steam from the drum and passes it through the radiant and convection superheaters. About 1/3 heat for convection radiation superheater passes to the turbine. 2/3 is brought to the water evaporating drum to heat the feed water. So what is the advantage? As it is having two pumps, one is feed pump and another is we are pumping the steam only from the steam drum. So because of that, salt concentration on the pipes will be less because of the high pressure is pumping. We are taking more amount of wet steam, more compact, very simple in design, easy transportation, and capacity is moderate capacity. Medium capacity, normal range for processing in other industries, they will go for 50 tons, right? Lemon boiler. And medium size industries where we are going for Bunsen boiler and other higher capacities, right? Higher capacities, if you want, they can go for Leffler boilers, because the Bunsen boiler is 170 tons per hour. The Leffler boilers are 100 tons. So this may be a medium capacity. Bunsen is the highest capacity, high pressure and high temperature. Here it is 140 bar only. If you are going for Bunsen boiler, it is 170. 70. Capacity is also high, pressure is also high in case of Bunsen boilers. So Lehman boiler is used for small scales. These low floor boilers for medium scales, and high capacity they are going for Bunsen boilers. So if we are discussed so far what is meant by boilers and how this water is converted into a steam in the boiler, the device we discussed, right? So next class we will see what are the accessories which is used to improve the efficiency of the boiler. We want to discuss those accessories. What are the different components one by one? Previously we are seeing what is economizer, all those things, just an overview. So we will see in this accessories, we will see one by one what is its function, what is its functions. Okay, thank you gentlemen. We will meet in the next class. Thank you.